All right. Hello, my name is David Herntzer, and I am a regional technical expert for Hashmap NTT. So what are we going to cover for this Snowpark demo today? First, we're going to cover Hashmap in 1. We're going to go over what Snowpark Python is. We're going to talk about some HL7 messaging data inside of healthcare, and we're going to give a Snowpark demo that is going to go process HL7 data all via Snowpark. So Hashmap, who are we? We are the data engineering company under a very wonderful organization called NTT Data. We are primarily a data and cloud solution integration and consulting services company with over 350 data and cloud projects since 2018, and we are a very community-driven organization. Our 3 areas of focus are designing and building modern data products, caring and focusing on what works best for you, the client, and sharing our IT and data insights. As you can see from the list at the bottom of this slide, we have what it takes to move you forward on your data journey. So why are we here? Of course, it's Snowpark Day, and more importantly, Snowpark Python Day for us. To those who are wondering, we summed up Snowpark Python in 5 main points. All right, number 1, Snowpark API provides programming language constructs to build SQL statements via functions and dot notation, thereby utilizing intelligent code completion. What that means is as you're typing, the code completes for you. Number 2, Snowpark operations are lazily executed. Think pushdown SQL on the warehouse, right? Thereby drastically reducing the amount of data that's pushed to the warehouse and pulled back out of the warehouse. Number 3, Snowpark core abstraction is a data frame object, not a data frame dataset, piggybacking off of number 2. Then number 4, Snowpark allows for the creation of user-defined functions, UDFs, for complex code processes so they can be pushed down and run on Snowflake, right where the data is, versus pulling the data out and operating on those things inside of memory. And 5, last but not least, Snowpark Python's programming language is, well, Python. So what are some key use cases? So if you look on the blocks on the left here, mainly data transformation, data preparation and feature engineering, ML scoring and prepping ML models, and ELT systems, of course. So what does this mean? What does this offer? Let's quickly go through this list and delineate these. You can write in your own language with your preferred tool. You can easily complete and debug pipelines with familiar constructs such as data frames. You can utilize pre-built third-party libraries, eliminate the need to have other processing systems, and run things directly on Snowflake. You can collaborate on the same data in the same platform. You can utilize Snowflake Data Cloud with superior price, performance, and near zero maintenance. You enforce consistent enterprise-grade governance controls and security across the workflows. You bind SQL functions to implementations outside of Snowflake in all 3 clouds, and build Python-based UDFs and Python scalar functions, and really, you can use these wherever functions can be used. The diagram here illustrates how the Snowpark API integrates the development environment and Snowflake processing environments. As you can see, Python is just the newest feature being added to Snowflake's Snowpark, joining a multitude of existing programmable languages such as JavaScript, Java, and of course external functions, as well as allowing you to customize your own IDEs. Okay, so really what does this mean? This means there's a better way to do the common development and discovery tasks needed in today's fast-paced environment. Let's quickly go over these on the left. So before, when you think about these complex workloads, right, you need to have a separate processing clusters, right, for users who have different language preferences. Unnecessary data pipelines with lots of data movement and lots of data silos. And sometimes a loose governance control and security loopholes can exist. After streamlining with Snowpark and Snowflake, you have one single platform with native support for different language preferences, streamlined architecture and collaborate on the same data, and consistent governance and security policies. So what does this mean for today's session? Well, HL7. Our use case today is going to be HL7 data. So one of the biggest challenges of having data is really having usable and trusted data. Think of the complexities involved: numerous data sources, speed in which data is consumed, data lifecycle, data wrangling, data movement, data cataloging and governance, as well as data sharing. All of these come into play no matter what industry. And speaking of industries, we're showcasing the healthcare use case, but truly every industry is dealing with similar issues when it comes to getting value from their data. No matter if you're manufacturing, financial services, energy, healthcare, or any other, various standards, governing bodies, challenging industry-specific file formats, mechanisms for transport, all of these play a factor in business outcomes. So our demo today is focused on HL7. So some folks may have never heard of OSI, right? OSI, before I get to HL7, OSI stands for Open Systems Interconnection Model, if I can get that word out. So when you hear of OSI, really think of standards for interoperability, right, of these diverse communication systems. HL7 simply refers to a set of standards used for transferring clinical and admission data among healthcare providers. And you can see it's called HL7 because it sits at the OSI level 7, which is the application to application or system to system data communication level. And really, HL7 is that standard that empowers global companies, right, that interoperability in between their systems. All right, so that's the good. Now the bad. The bad is that the HL7 message formats really didn't have a solid start, and the message formats have truly not had, they really haven't been able to keep up with technology as technology has been changing. So what this means is that we have a few variations of these messages. And I know what the first person to think is, well, why don't we just all use one message type? Well, the problem is there are numerous types of systems, and some of these systems that are in use today date way back, and I mean way back, and a lot of them are not easily updated to use XML or JSON. Here are some of the formats that are used today, and you can see there's about primarily four of them here. So HL7 V2, and that is the format we're going to go over today. You can see it's the most complex. HL7 V3 gets a little more refined. This is an XML format, and CDA is a domain-driven form of HL7 V3. And the last but not least is the FHIR format. And this is the most recent standard. This is more of a JSON format. Everything all passed through REST APIs. All right, so here's a list of what we'll do as a part of our demo. We're going to get some HL7 V2 data to look like the FHIR format. So our use case, if you will, is I want to create a patient 360 data analytics data set. Basically, data sets that allow numerous use cases to be processed from them. So you can see from the slide here that we're going to be wrangling patient admission data and medical observation data regarding those patients. So our key issue here is that these systems use HL7 V2, but I want to have my data set, maybe my data apps that are going to be built sometime in the future, to be able to access a set of maybe Snowflake tables or some shared data sets or APIs, and not some data that's sitting in a data lake and holding all this unformatted data. So the question is, how are we going to accomplish this? How are we going to get this data transformed into some uniform, usable format? Is it going to take 5 systems? Is it going to take 10 systems? No, just one, Snowpark. All right, the Snowpark demo. This is the part we all want to get to. Let's get going. Let me switch over to that screen real quick. All right. And what I wanted to point out real quick behind me before I get started, getting a lot of this stuff set up, you can see here I have everything set up in one Jupyter notebook. Very simplistic, very easy. Not very difficult at all, considering I had to build a snowflake out of paper, which I haven't done since probably kindergarten. That was probably more difficult getting that done than getting this Jupyter notebook set up. So what are we going to do? The title is a Patient 360 HL7 V2 Discovery. Let's quickly go over what we're going to do here. This notebook will use the Snowpark Python API. We're going to utilize an internal Snowflake stage. We're going to load all needed files into that stage. We're talking data and the Python files. We're going to build a dynamic UDF. Remember, not one that we're coding and storing inside Snowflake. We're going to build a dynamic UDF inside this Jupyter notebook. That's going to be the entry point for this third-party package. And we're using an open source HL7 reformatter utility that's already pre-built for us. We're going to parse some HL7 V2 patient admissions data and some observations data, and we're going to stage that into JSON. We're going to store that JSON into a Snowflake table, and we're going to transform that JSON into some denormalized Snowflake data sets or tables for us. Then we're, of course, to have fun with this, we're going to act as various players to consume this data. All right, again, all via the power of Snowflake. So what I'm going to do, you can see at the very top of the screen, I have two tabs here, and one is going to be the worksheet. We're going to jump back and forth between the Jupyter Notebook and the Snowflake UI, because I wanted to show you the transformations of this data, what's happening inside Snowpark as in what it's getting translated to on the back end. So let's go ahead and start. The first thing we have to do is we have to set up our session. Very simplistic. And before I set this session up, I'm going to go ahead and change my query tag. What I want to do inside my query history is I want to be able to catalog all the things I'm running right now, but with a different tag. So I'm just going to put in here Snowpark Demo. There we go. Now I'm going to control enter these. I'm going to just run these with the keyboard. There we go. You can see I got my confirmation there. Everything's running fine. I'm going to go ahead and set up some variables that I need for my Python stuff. So you can see a lot of these things are going to be pulling files from my local file system. And I'm going to be putting them out into a stage. I'm going to build that stage right now. Let's go ahead and run that. All right, stage is successfully created. And this next one is just kind of demonstrating some of the things that come back. You can see I can show, this is Python, right? So I can bring back an object. I can show you the type of the object. I can pull out a piece of the object, like the row itself. I can show the entire list, or I can pull out a piece of that row, like current user. Just want to kind of demonstrate that. This is full Python, right? Full interactive session. All right, next, I want to upload the files. So let's move the needed files into the appropriate stage location. Again, I'm going to have two sets of files, right? One is going to be that third-party package, that zip file. And again, you can see I don't have to compress that one. It's already compressed for me. And next, I'm going to move some sample data file up there as well. So let's go ahead and run that. It should give me some results if it all worked correctly. There we go. Let's make sure. So status is uploaded for both. I'm printing the entire list structure out here. And you can see my compression was none on that zip file, and it was going and gzipped for that sample data file. So all good there so far. So we're going to load the HL7 file. And I just want to give you kind of a sample of what that looks like. I know we saw it kind of previously, but I want to kind of go over this sample and why it's a little bit difficult to read and why it's a little bit difficult to operate on. You can see there are various formats here. There is no primary delimiter, right? You can see there it has a caret, it has a tilde, a backslash, an ampersand, and of course a pipe. But not just that, this entire structure here represents one record. And technically it represents multiple records all tied into one message. So it's a little bit different to interpret. You can see the next one starts after a blank line. So what we're going to do is we're going to take this, all these messages, and they're in one file. They're all mixed up. It's observations and admissions, all in one file. We're going to take this data and we're going to we're going to call it a string, and we're going to pull some pieces out, and we're going to go ahead and load that into a data frame and just really get out all those blank lines that we no longer need. Let that run. Takes a few seconds. There we go. Now I can see my sample data coming out. And I have, again, looks really nice now. What you can't see behind here, of course, is there are still carriage returns. There's only one line feed now per row. So all those constructs you just saw about all those records they're still all there. Again, they just get flattened out into one big string. All right, so I'm going to save this raw data to a table. So let's go ahead and write it here. All right, so now I saved all that data into unparsed HL7. So now I'm going to jump back over to my worksheet, and I'm going to hopefully refresh. I should see. There we go. I have unparsed data, HL7. I'm going to go ahead and preview that data. And you'll see it's a whole list of everything I just showed you, or kind of the sample I just showed you. But all those records now are broken out, and you can see there's one record that goes all the way across for all of these. Jump back in here. All right, so let's sample the data from this table. Again, we just saw that, but when I bring it back in this row construct, now you can see it. It's all one big giant string, and there's really only one line feed that was used to actually call that, or to denote that record identifier right at the very end. All right, all good. I threw in some optional things here just to kind of show you some more power of Snowpark. I can save this back. So say I'm formatting some data, and some other people maybe want it in a different format. I can do that. So I can go ahead and create this. I can write a copy of this out to that stage. I'm using a single stage here. Of course, you would have import and export stages. You'd have code stages and everything else where you want this code to reside. But again, I'm kind of doing this discovery. This is kind of a development effort, kind of a more R&D effort. So you can see it exported 1,013 records. I can go ahead and run this again. Again, this is Python, right? So I can go ahead and say print record count. Go ahead and go get that data frame, collect it, and give me the length. Of course, since it's a list, it's going to give me the actual count of rows. All right, real quick, we're up to our first checkpoint. So, and again, I'm trying to go through this quickly, so I'm not taking 3 or 4 hours of your time. So far, what have we done? we have created some Snowflake objects, right? And we have uploaded our code file. We uploaded a data file. We created a single string for each of those messages. And we saved all these messages to a table. And we exported that parsed message data just so we have a copy of it. Pretty simple so far. Now we're going to get to the meat of this, parsing that HL7 v2 data into JSON. The first thing I have to do is create that UDF. Now there's quite a bit of code here, and you wouldn't have to do this normally. A lot of this code is in here. I'm not going to go through all of it. It's a lot of Python code. But what this is really doing, this is creating that entry point. This is creating that function that I can call at runtime, where I can call it via a select statement, or I can call it via my Snowpark API. And this is done primarily because the manner in which this package was built, everything has to be extracted out of that package and used a certain way to actually use this package inside Python. You can see at the very bottom here, it's going to register this this UDF for me called HL7 PyParser SnowPy. So I'm going to go ahead and run this. It only takes like a second to run this and make sure I kind of scrolled too far. For those who know Jupyter, right, when this goes from an asterisk to an actual event number, then we know we're done. There we go. So now let's go ahead and try it out. So now you can see what I'm doing here in my first test is going to be with a select statement. So I'm simply going to run a select statement inside the Snowpark API, just like I would inside the Snowflake UI. But again, everything's happening locally here, right? All my development is inside this Snowpark API, all running local. So I'm just going to say select the unparsed data, and now you can see I'm going to also run that function on that unparsed data. And I'm going to call that parse data when I come out of it. Again, all this is doing is just running a select statement, doing nothing else. You can see now I get the difference here, right? So I said, show me one of the records. Here's what it was before, that giant humongous string. And look, now everything is nice and pretty in a good JSON object. Nice. All right. So now we're going to do the exact same thing, except we're going to parse this with dot notation, right? With Python. Looks a little different, right? There's no select statement anymore. What I'm saying is I'm going to create I'm going to go ahead and grab this table. I'm going to run a select on that. In that select, I'm going to go ahead and run this function. I'm going to hit this column, and I'm going to call it this column on the output. I'm going to remember this is all just a Python object. Then I'm going to say I'm going to create me a data frame writer, and I'm going to put it in overwrite mode, which there's no table there anyway. But I'm going to put it in overwrite mode, and I'm going to call this table, this new table, parsed HL7. So I'm going to go ahead and kick this off. And while this is running, it should take a couple of seconds. While this is running, I'm going to jump back over here to my history because I want to show you some of the things this is doing behind the scenes. So you have a bunch of junk in here. I'm going to go ahead and change this query tag to be Snowpark Demo. I think that's what I called it. Let's hope I did. And it is. And you can't see it's a little bit off to the right here, but there's that query tag. I have my screen zoomed in a little bit so we can see it a little bit better. But now all of my statements that I'm running from my Jupyter notebook where I changed that query tag on my session, all those now show up and I can see just what I want to work on, or just the ones that are pertaining just to what's in my session. So you can see right now it's running. I'm going to go ahead and open this query up. So even though I did dot notation right, it was all Python, behind the scenes, what Snowpark API did was create a CTE, right? So I create table as, here it is, parsed HL7, and it is going to run that function, right, that I created and I pushed up dynamically on this unparsed data column. It's going to call it parsed data, and it's pulling everything from this unparsed area. Awesome. You can see some of these other ones as well, some of the select statements. Here's the one prior to it. Same exact thing, but again, it's a straight select statement. So I'm going to jump back over here. It's all said and done. Now, everything now should be converted. So if I jump back over to my worksheet, I'm going to see some additional tables in here. There we go. So I see this unparsed file, which has, we just saw a minute ago, has all my unparsed data in it. Then now I have the parsed data. And of course, since it converted everything to JSON, it's going to be inside of a variant column. So if I wanted to preview that, I can see that in here as well. Just wanted to show you. And this other bad JSON table, we're going to talk about that right now. So just because I converted this JSON and everything looked like it worked just fine, I didn't get any errors back, it doesn't really mean that my data is valid, right? I'm trusting some other utility to convert this data. I want to verify it. Of course, one of the great things you do if you're doing semi-structured processing inside of Snowflake is use the check JSON function, right? Well, I can do the same thing. They've built me and then interop for that, I can use the exact same function, this check JSON function, from within my Snowpark API here. So you can see I'm going to go run this check JSON. I'm going to run it on this bad JSON table. Now, this is some data that I already messed up, and I stuck it in there on purpose just so I can get an error, and that's why I called it bad JSON table. And there we go. I'm even spitting some of the object types out of there so you can see it as well. Now what this is telling me, this should have came back with no rows. I'm saying go out there and run this check JSON on every value in that table. And then I'm saying filter this where it is not null. So every time it runs, I should, if everything works perfectly and checks the JSON out, I should get a null back. What I'm saying is when you go to collect these stats, when you go to collect these rows back, give me everything that's not null, which means all my errors. And of course, for this one, I had one in there. And somewhere, I think it's right here, I took out a brace just to make it fail. All right, now what we're going to do is we're going to do the exact same thing, but on the data we just parsed. Let's hope I don't demo and die. There we go. Awesome. You can see I print out a message right here that says JSON check passed. So just now it went through all 1013 records and went ahead and checked all those and validated all the JSON. Now, of course, in the real world, right, you would do a lot more than that, wouldn't you? Excuse me. You would be writing other checks as well, right, to make sure all the JSON is actually built like you want it, right? All the values you need are there. Here I'm merely checking the JSON structure to make sure it is valid. Right, so now let's say I'm done with that, everything's great, and again, now I want to be able to take that file, maybe I have a coworker that needs it. Again, I'm just going to show you some more pieces that we can use out of the Snowpark API. So I can go ahead and run this statement here. What that's going to do is it's going to write me a copy. So now instead of pushing data into Snowflake, I'm pulling data out. So I went and queried all that parsed HL7 data. I created a writer. I copied it to a location. It's just like an unload statement, right? And it's going to go and build me some JSON. Now, if I really want to, I can run the exact same command. I can run the next command, which is going to take those files that were built, file or files. Looks like there's maybe, what, 1, 2, looks like there's 3 files that built for me here. It's going to take all 3 files and pull them down locally. And now I can use those files for other things if I want to, versus having to run through this whole process all over again. Really nice, really powerful. All right, on to checkpoint number 2. So here we go. So far, we've used Snowpark to create an HL7 v2 parsing UDF. We ran a sample parse via that select statement to make sure that our function was working. We utilized that UDF to parse all the records in that unparsed table and convert them all to JSON. We saved that JSON to a new table. Then we validated all the JSON to make sure it's exactly what we needed. Then we export that JSON just to have a copy of it. All right, now we're on to the final leg here. This is the data curation pieces, right? Now I know when people see this, they're going to go, wow, that looks like a lot of SQL. It's actually not that complex. When you look at this, what we're really doing is this is semi-structured data queries, right, for the most part. This is one thing that Snowpark is not able to do yet. So we're putting all this into queries. It's a little bit complex to operate on this stuff. All this giant statement here is doing is truly just saying, go into this column in that table, track all the way down this object, right? So in the JSON, go to this object. Every time you see a period, this object, it goes all the way down to the value it needs. It says, go get me this value. I want it to be a string, cast it as a string, and then call it this. And I'm doing that for every value that I want to keep out of this JSON. There's quite a bit of data out there. The HL7 v2 format has probably hundreds of different fields. I pulled out maybe 30 of them. Now this also gets a little bit complex because what I found out after trial and error, when I ran this on the data, I was getting a bunch of nulls back where I shouldn't have. And what I found is that the HL7 parser does a couple of weird things where if it finds a single item in like maybe a single observation tied to a message, it creates an observation object inside that JSON. If it finds 2 or 3 observations, it creates another object that's an array and then loads that array. So it actually changed my JSON structure. So I had to use 2 different methodologies for getting all that data out, which is pretty easy in Snowflake. Just kind of highlight that, is that I can use the isArray mechanism, right? The isArray function to find out which ones are which here. So in this first one, I'm just saying if this is not an array, which means it's one value, that means the converter put it into one object. I can pull those out, no problem. And you can see this is for the observations. ORU and RO1 are the events that occur to give me an observation. The second one now is a little different. The second one I'm saying now there's an array. So now I have to build multiple records. So again, I can use that isArray function, and all I have to do is run this lateral flatten. And again, this is all inside the Snowflake documentation. And you can see with the SQL changed a little bit. Now I'm using those flattened values with this value statement here to pull all the values out. Nice and easy though. Again, looks like a lot, but it's really not a lot. So I'm going to go ahead and run this. And all this is going to do, this is going to, again, go very quickly. It's going to go over all those JSON records that are in that raw table. It's going to create me a table called bronze OBS HL7. So at this point in time, you can see it printed out 3,323 records. So at this point in time, I should have another table sitting out there. So if I go over to my worksheet here and I hit refresh, there we go, bronze OBS HL7. And you can see this is a rather large table. And what I did just to help me out and help my analytics guys out, or maybe my engineers that are looking at this data, I also prefix it, right? So all of my observation stuff is prefixed with OB, of course. Any of the patient visit is prefixed with PV. Any patient information is PI. And I also kept the message information, so MSG. So I can literally run analytics on the types of messages I get, the number of messages. I can run analytics across all of this data. And of course, in the real world, this would ultimately be, more normalized, more parsed, better. But for the purposes of this, I really want to be able to get to this data and investigate this data really quickly. So let's jump back over here. We're going to do one more. We're going to curate that admissions data. And you can see this is a little bit smaller because, again, on the admissions data, there was no variations, at least none that I found. Everything came out with data. There was no possible list constructs that were throwing things off. So I could literally query the JSON as is, pull the files, pull the fields out that I want, and I got around 400 different admission records. All right, so let's jump back to our worksheet again, and let's go ahead and make sure I see what I see here. All right, there we go. Now I have my bronze ADM HL7 table, and you can see it's all full of just the patient admission data sets there. Nice, and I can preview that as well. And now you can see, of course, there's no longer JSON, right? Everything's parsed, everything is typed. That's one of the great things about the semi-structured data queries, right? Is I can parse, I can denote the type and everything, and build out my table right away. And if you want to look at that, I can go back into my query history. And my query tag is still set, good deal. And I can go and look at this create statement. Which, remember, all I did on Snowpark, I just said, hey, select this data, right? But since I told Snowpark API, hey, I need a table out of this, so create me a writer and create me a table, Snowpark go ahead and builds the create table as for you. Very nice. All right, at that point, guys, believe it or not, we're actually done. We got all our data, we bulked everything in, we got it converted to JSON, and we also got it now curated into formats that I can actually use and run some good functions on, right? Run some analytics on. So let's have a little bit of fun with this. So let's go and view some of that curated data via some of the scenarios we were talking about a while ago. So let's say I have a patient portal and I want to give some functionality to a patient. And again, this is all raw data, but we're just playing around. I want to give some functionality to a patient. So this first query is to query in for about my last hospital visit. So you can see I'm actually running a query inside Snowpark. So remember in Snowpark, I can actually create a SQL statement and run that SQL statement if I want to. So I'm going to go ahead and run that. And you can see when I said show, it prints me out. It's a little bit hard to read. Everything's wrapping, but that's all right. It's pulling out my last visit and everything with it. The date of the visit, the hospital, of course, this is simulated data, so it's simulated hospital. The attending physician, it was an inpatient, right? It wasn't outpatient, it was inpatient. Here's the ID. So if I have to go look and maybe question a bill or something like that, I have my visit number, date of birth, address, everything else is in there as well from that visit. So pretty nice. Let's say, okay, on that visit, let's pretend I click that visit and I want to see everything that was done on that visit. Now here you can see it's a little bit different. So now we're going to query the observations, but we're going to query the observations kind of based on that dot notation, right? Instead of making a select statement, I'm going to go ahead and use Snowpark API and use the Python behind the scenes, kind of more as a developer or engineer would on this. So you can see it's constructed a little bit differently. So I'm going to go ahead and run this. It's going to do the exact same thing. And we're going to look at those two queries right away. And you can see exactly what was done. So I'm pulling back all the lab results basically, and you can see this person had what, 1, 2, 3, 4, looks like 5 different, oh yeah, here's the order. So there's 5 different lab results that were done on that one hospital visit. So that quick, a patient has access into their data. Let's jump over real quick to this query history. Let's refresh this. And you can see the first one I ran was a select statement, right? We know that. The next one, I didn't run a select. Remember, I actually used the Snowpark API. Snowpark behind the scenes is going to come and build all this SQL for me. So some of this complex SQL that maybe, and some of this gets really complex, it may be too difficult, or not too difficult, but it may take you a long time to figure out. Or if I had to say, give me this column, this column, this column, and run this function and run, Snowpark will build the SQL for us in the back end. So very nice. All right, so that's the patient scenarios. Let's run two on the doctor scenario. Let's say I want to review my patient's admission history for all of my patients over 65. Maybe I'm running some studies. Maybe I'm doing a study for a medical journal, and I want to maybe look at my patients and maybe ask them some questions, maybe interview them about different things. So if I go in to run this, again, it's all using dot notation. That quick, I can go back and find information about all my patients over 65. You can see I got quite a few back. I can get their address. And if I really want to, I could run some additional functions, right? That could do mapping, maybe give me everybody back who's within 10 miles. This is all Great Britain, I think, data, but regardless, I could run some additional functions on this to figure out maybe who might be my best candidates to help me out with this study. So very nice. Let's run one more as a doctor. You see I changed it back to a SQL statement just to change it up a little bit. So let's say I want to go back and look at orders for lipid panels. Maybe I have somebody questioning something. Maybe there's some new studies coming out, and I want to see everybody who I'm putting out tests or I'm administering tests for lipid panels. I can do that. I can come right back. I can find everyone who had a lipid panel. I can see their cholesterol, their triglycerides, everything that's inside there. Very nice. All right, last but not least, another scenario I thought of was possibly introducing maybe a product or service vendor or like a medical institute, someone who wants to do some studies on this data, right? So maybe not exactly down to the patient name and address, but some more of the clinical stuff. So let's get a list of all doctors who see patients for endocrine issues. So high creatinine clearance levels, those type of things. And again, this is a very large, very complex SQL statement. And again, I left it as SQL just to change it up a little bit. Now here we go. I get the hospital, I get the attending physician, and I get how many female patients, how many male patients, and of course the total number of patients here. You can see the SQL statement is rather complex, but not super complex. But this fast, I'm getting insight. If I was able to query this data set, maybe as a shared data set, I'd right away know, hey, what doctors, I can say maybe anybody above 20 patients a month. So I can go look at from this Wolfson all the way up to Smith. I can say, look how fast I get insight to go figure out what doctors would be great candidates maybe for these new clinical trials. Again, healthcare is all about making the patient better, right? Keeping everybody healthy. So let's go ahead and see if I can contact these doctors and at this hospital and start these clinical trials for these new, maybe these new renal medicines or renal processes. And lastly, we have one more. So I'm going to say the same thing as a product or service vendor or medical institute. And I want to see some analytical trends, maybe on these observation types, right? Maybe hospital material services related. So I'm going to go ahead and run this. And now what it's doing is it's kind of reviewing all the observations in general, right? All the messages that came across. And it's saying on average for this hospital, right? I'm seeing this types of counts for things that are being performed at this hospital. That can help hospital administration. It can help for contract agreements. I used to work a long time ago in some of the healthcare industry, and I remember we had to build a system because some of the hospitals mainly deal with cancer patients. Some don't. So they kind of formulate their pharmacy contracts and their hospital material services contracts based on the type of services they usually do, right? And so this information can really help hospitals lower their costs. Of course, everything gets passed on to the patient, right? So any of this analytics data can really help them build a better contract, maybe keep more stuff in stock, maybe less expensive stuff in stock to help out with the services they provide. Everything at your fingertips using Snowpark. So I'm going to go ahead and end my session here. And let's see, I believe, yes, that's it. That's all I have for the demo today, folks. And I really hope you enjoyed it. And I hope it helped you understand the power of Snowpark and the power of the Snowflake Data Cloud. Thanks again.